we go. Alrighty, hello. The lesson we're looking at today is based off of what we did yesterday with graphing systems to solve. We're going to apply everything you did yesterday to our favorite thing ever, so some word problems. So the first thing, that objective says exactly what we just said. We're going to graph systems of equations and use those graphs to help us answer word problems. This is going to use a lot of what we did yesterday with solving systems by graphing, but it's also going to use a lot of what you learned back in Algebra 1A with representing word problems with equations. The difference is instead of one equation, it's going to be a system, which we learned 2 days ago. What is a system?
Like a set of equations.
Yeah, a set of equations, two or more equations. So it's going to be similar to what you already did with word problems, just more, because more equations. So to start us off, I've got this word problem here we're going to look at about temperature. So in the first part, it says, today the average temperature in New York is -1 degrees and is expected to rise 3 degrees per day. And the first part's asking us, write an equation to represent the temperature in New York. We've done something similar to this back in Unit 1 of Algebra. If I wanted to represent this with equation, what could I write down?
Do like y equals like 3x minus 1.
3x, ooh, look at you already putting it in slope-intercept form. Tell me where you're getting this from.
So the -1 is the y-intercept, which is where you start. And then each day you go up by 3 degrees, so that's the 3x. X meaning each day.
And I love how you're telling me what the variables represent too. So what I hear as you're describing this is you're thinking it sounds like what the graph is going to look like. I heard you say the -1 is that starting point. It's saying the temperature is starting at -1 degrees. And then we've got a positive 3x because it's going up 3 degrees per day. And I also heard you tell me that x is going to represent the number of days. Along with that, you used y. What does y represent?
The temperature.
Nice. I was going to say, when in doubt, read what the question's asking. Write an equation to represent the temperature. So we are saying, I'm going to write temp, that our temperature equals this. I'm going to clarify, for New York. So this next one is also talking about temperature. We've got Alaska now. The second part says it's 6 degrees in Alaska and expected to fall 1 degree every 2 days. Write an equation to represent the temperature in Alaska. What I was going to say up here is it doesn't matter which variables you use. It sounds like because you're already thinking graphing, you're using x and y, and you already put it in slope-intercept form for us. Whatever variables you use up here, let's do the same thing down here. So up here, you were using x for days, y for temperature. Let's be consistent. So down here, if I want to write an equation for the temperature, it's going to
be y equals 1/2x
plus 6. Let's start in the same place you did last time. So earlier you said the y-intercept 6 represents
6 degrees, which is when they start.
Yep. How are you getting 1/2?
Because every day, or every 2 days, it goes up 1 degree, or it goes up 1/2 degree every day.
So at like starting point at day 0, it's 6 degrees. I hear you said every 2 days, it's going
Up 1, or falling 1.
Falling 1.
So it would be -1/2.
Nice. It's falling, so that's telling us, that looks weird. I'm going to write negative. So after 2 days, it's fallen 1 degree, which means 5. If I wanted to put in that little line there for 1 day, so at day 1, it's fallen
5.5 degrees.
Nice. So 5.5 or 5.5. You caught onto that very quickly. The part here with 1 degree every 2 days that students like to write a lot of times is 2x. How is this different than this?
Yes. 2x would mean it's changing.
Or I guess I should put negative there.
Well, it's changing by 2 every day.
Changing by 2 to what?
It's changing 2 degrees
Mhm.
every day is what the bottom one says, and the top one says it's changing half a degree every day.
Nice. So it's dropping half a degree every day. This is dropping 2 degrees every day. We could say dropping 1 degree every 2 days versus dropping 2 degrees every 1 day. But they mean different things. So you caught that half. That's awesome. So if I pause here, the variables are the same, I guess. Let me put that. X is the number of days. And then Y is our temperature. But this time it's the temperature in Alaska. So looking at what we've got written down, if I wanted to put this all together, I've got 2 equations. I could say I've got 2 equations, or I've got, you told me earlier, what is a set of equations called?
System.
Yeah, we've got a system of equations. I know it's a system because there's more than one equation, but those equations are using the same variables. They're referring to the same things. Both of these we're talking about the temperature over a certain amount of days. Now that we've got a system here, the next thing I'm going to have us do is graph it. You did us all a favor. You already put them in slope-intercept form. At this point, if they weren't already in slope-intercept form, my first step would probably be changing it around. We've got, I'll put it over here, y equals 3x minus 1, and y equals negative 1/2 x plus 6. This one was for New York. This one was for Alaska. So the next part is saying graph both equations. It must be below on your paper, but over here, not below. Graph them over here on the graph. So if I wanted to graph that first one, that equation for New York, what would that one look like?
So you would start at negative 1 on the y-axis,
Mm-hmm.
and you go over 1 up 3
Mhm.
point,
Yep.
and you would just keep going in both directions till you couldn't anymore.
Keep going in both directions until we couldn't anymore. Anything else you want to do?
And then fill a line through the dot line, or through the dots.
Yep. So I'm going to have us pause right here. So we've got this line. Remember we said this equation here is describing the temperature in New York. So I could see this point right here. You had already told me earlier what this point represents. This represents
The y-intercept,
mm-hmm.
and or where you start.
Mhm. So this point right here is telling me where I'm starting at a temperature of, what number would that be?
Negative 1.
Negative 1. What about this point? This point represents what?
2 degrees,
Mm-hmm.
and then
2 degrees, 1.
after the first, or on the, I guess the next day.
Mm-hmm. So our starting point, day 1, the temperature was 2 degrees. Then we've got day 2, the temperature was
5 degrees.
5 degrees, and we keep going. What about this point? What does this point represent?
The day before the initial day.
How many days?
1.
What number is there? Negative 1 days. When it comes to time, can you have negative 1 days?
No.
I love what you're thinking. It's about the day before. But that information they gave us, it's just saying this is where it's starting and this is what's happening. If we knew that that same thing was true going back in time, then we could do this. But they didn't say anything about yesterday.
Yeah.
So if we're reading it like simply as like day negative 1, I saw you're like, maybe not. One of the things when you're graphing word problems, we saw it back in Algebra 1A, and the same thing is true here. On these graphs, when you're looking at word problems, you want to see if what you're talking about makes sense with negatives. So in this situation, that x-axis, you were saying it was the number of days. Here, do I want to point here for negative days? No. So how do we want to change our graph a little bit?
You would erase the line, everything before the y-axis.
Yeah. Do you think that's always going to be true?
No.
If x-axis instead of days was talking about something else such as,
An amount of something.
be more specific, like an amount of human beings?
Yeah.
Human beings, could they be negative?
I guess so. No.
Can I have negative 5 people?
Personality.
You can be negative in personality, but like a negative, can I have negative 3 people in this room?
No.
So it couldn't be amount of humans. It could be something else though.
It could be like money.
Yeah.
Like a product.
Yeah, so if this x-axis was talking about money, then definitely that line could keep going, right? If this was my bank account, your bank account could get into the negatives. It's going to all depend on what we're talking about. Notice our y-axis. You put a point down here in the negatives. What was our y-axis talking about?
The temperature.
Temperature. So temperature can be negative. That makes sense. But negative days, I really like what you said about like yesterday, but we didn't have that information about the previous days, so we can't have negative days on our graph. That was our first line here. What about that second line?
Starts at positive 6 on the y-axis
3, 6.
and then goes down 1 over 2 each point.
Why are we going down this time?
It's negative.
The slope's negative. And then what did the story say? Where did that negative come from? Do you remember?
Because the temperature would be decreasing each day.
It's told us the temperature is dropping 1 degree every 2 days. It looks like it makes so much more sense when you've got a graph. You can literally see it dropping 1 degree every 2 days. So I've got those points. Both directions?
No.
Nope. So then I can just go ahead and draw our line like that. If I go back to the question, it says graph both equations below. Make sure you label the x and the y-axis and label which line is New York and which line is Alaska. At this point, all we've done is graph the lines. You were already telling me earlier about what x and y-axis represent. All we're going to do is add in those words you were saying earlier. So earlier you said that x-axis is
The amount of days.
The amount of days. You could say amount of days, number of days. And then our y-axis?
Is the temperature.
Yes. So we labeled our x and y-axis. It also wants us to label which line is which. So on my board, I imagine both of yours are in pencil, but on mine, the line going up in black, that was describing the temperature of which place?
New York.
And then that blue line would be the other one. That would be Alaska. Okay. So we've got our graph of our system at this point. The last part of this is asking, now that we've got the graph, there's some stuff we can learn from this graph. If I'm just focusing on this line for New York, what do I notice from looking at the graph?
The temperature is increasing.
Love it. Temperature's increasing. Alaska?
Decreasing.
Temperature's decreasing. Awesome. Looking at the entire system, so looking at both lines at once, thinking back to what we talked about yesterday, is your eye drawn towards something?
There's an intersecting point.
Yeah. I'm going to grab a red marker. Yesterday, we had been really focusing on that intersection point when you're talking about systems. Before, we just called it the solution point, and we were done with it. Here, because our system is talking about something, it's talking about temperature, the amount of days, this point it means something. It's significant in this problem. What does that point right there tell us?
When the temperatures would have been the same.
Yep. So this point here is telling me the temperatures were the same. The temperatures were both, what temperature is that?
5 degrees.
The temperatures were both 5 degrees. Give me a little more information.
On the second day.
Nice, on that second day. What we were doing yesterday was labeling the point. We were saying it's the 0.25. But what you've done is gone a step further now, and you're telling me that 2 is the number of days, the 5 is the temperature. So something, if we wanted to describe what we learned from the graph, we could say what you just said. We could say the temperature was the same on the second day. I could add a little more to that because I'm talking about the second day. I'm saying the temperature was the same. What else could I add to that?
It was 5 degrees.
Yep. So the temperature was, I'm going to change, was 5 degrees for both places on the second day. That's really what I wanted to emphasize is the meaning of that point there. There's more you can say about this graph. We're comparing the two cities there. We're saying this is where they're the same temperature. Are they the same temperature any other day on our graph? No. You could finish this up by comparing what happened before that day and what happened after that day. So I could say before the second day, compare these two temperatures.
The temperature in New York, 4.
Mm-hmm.
The second day is only 2 degrees. And in Alaska is 5.5 degrees.
Mm-hmm. And you got specific. We could just say in general, the temperature before in New York is lower, colder. The temperature in Alaska is warmer. After day 2, just compare the temperatures.
After day 2, in New York, it is a higher temperature than Alaska.
Yep. So you could say after day 2, temperature in New York is higher. You could say after day 2, the temperature in Alaska is colder, and do even more comparison. But at a minimum, I really want to focus on what that intersection point there means. How are you feeling about this one? Good? I think you are too. Which means you are more than prepared to guide us through this next one here. How do you feel about that?
Yeah, that's fine.
I asked Denise earlier, similar to that last one, since there's 2 equations, there's kind of 2 parts to the question, and Denise agreed to be your partner. Normally there's more than one student in the room, and I have students partner up for this, but Denise has so graciously offered to be your partner. So if you guys want to pick...
How am I supposed to do this? And I think I would have to come here.
Oh, well, you want to do it on the board.
Oh, we're doing it together?
Yeah. Yeah.
Okay.
Okay.
Do you work at PHI, James?
I used to, yeah.
Oh, how did you get a mask from there then?
Mhm.
Okay.
I'm just going to leave this right.
Suppose you have $20 in your bank account. You start saving $5 each week. Write an equation for how much money is in your account, assuming you don't take money out.
No.
Denise, are you claiming the first part?
No, we're doing this together.
So,
you got 20 to start out with, you agree?
so that'd be the y-intercept.
Love that math vocab.
And then you increase by $5 each week. So from that, you can just make the equation y equals 5x plus 20.
Okay, I agree. Alright, that's our first equation.
Before you move on to part B, there's one more thing I'm going to ask for part A. Do you remember what else we did? You wrote your equation and there's something else we wrote down.
Oh, what X and Y is.
Yeah.
Ah, okay.
So X is money per week, and Y is the total amount of money.
Mm-hmm. I agree Y is the total amount of money, but look at X again. Remember, your variable is the thing you don't know. So as I'm reading the